ones you need for the quiz/test when the test rolls around. So explain the difference between a parameter and a statistic. So a parameter is used to describe a population. A statistic is used to describe a set of data. Explain the difference between P and P hat. P is the model parameter, or the probability of success. P hat is the observed proportion in a sample. What is meant by sampling variability? This is the variability you'd expect to see from one sample to another. What is meant by the sampling distribution model of a statistic? This is the distribution of the sample statistics or proportions from all possible random samples. And you'll need to highlight 3 and 4. So 5, how is the size of a sample related to the spread of the sampling distribution? The larger the sample size, the better the model works. Or the better the spread models the true sampling distribution. In an SRS, a simple random sample of size n, what is true about the sampling distribution of p hat when the sample size n increases? So when sample size n increases, the sampling distribution of p hat is more normal and centered around the true p. So these next two things are going to be formulas. So in a simple random sample of size n, what is the mean of the sampling distribution of p hat? Either mu is equal to p or mu of p hat is equal to p. And then the next one, what is the standard deviation of the sampling distribution of p hat? Sigma of p hat is equal to the standard deviation of p hat, which is equal to the square root of PQ over N. Actually, hold on. Need to highlight 7 and 8. You'll need those two. Sigma. But you'll need those two formulas. So what happens to the standard deviation of p hat as the sample size n increases? As n increases, the standard deviation of p hat gets smaller. Therefore, the sampling variability decreases and better reflects the model. And you'll need to highlight that one. So when does the formula square root of PQ over N apply to the standard deviation of P hat? It is when we know the population proportion P. When the sample size n is large, the sampling distribution of p hat is approximately normal. What test can you use to determine if the sample is large enough to assume that the sampling distribution is approximately normal? So we're using the 10% condition, and we're looking at success failure. The mean and standard deviation of a population are parameters. So I underline that. What symbols are used to represent these parameters? It would be mu and sigma. Then the mean and standard deviation of a sample are statistics. What symbols are used to represent these? And that would be X bar and S. And you'll need to know both of those. Whoa. Because averages are less variable than individual outcomes, what is true about the standard deviation of the sampling distribution of X bar? We expect it to be small. Just less variable. What is the mean of the sampling distribution of X bar if X bar is the mean of a simple random sample of size n drawn from a large population with mean mu and standard deviation sigma? The mean of the sampling distribution of X bar is mu. And then the same thing, but for standard deviation. So 16. The standard deviation of the sampling distribution of X bar is sigma divided by the square root of n. I'll make you guess on the next one. To cut the standard deviation of X bar in half, you must make the sample, or must take a sample blank times as large. So the sample would be n. So if you want to cut it in half, what would you have to do to the sample size? I'll look at the formula. It's a specific number. I want it to be half. I want to cut the standard deviation in half. So what sample size would give me a 2 in the bottom? No, that's what I'm trying to get. What needs to go under the square root to give me 2? 4. Not really sure where it disappeared to, but there should be a sigma on top of this here. When should you use sigma over the square root of n to calculate the standard deviation of X bar? Only when the population standard deviation is known. If sigma is not known, what can you use to estimate the standard deviation of X bar? And what is this called? So we use sample standard deviation when sigma is not known. It's called standard error. And the formula is standard error of X bar is equal to S over the square root of n. So that's for our sample standard deviation. And you need to highlight 17, 18, and 19. So what does the central limit theorem say about the shape of the sampling distribution? It says that it is approximately normal. The larger the sample, the better the approximation will be. And you need to know that one. So what does the law of large numbers state? It says that as the sample size gets larger, each sample average is more likely to be closer to the population mean So that's not one that I'm highlighting that you have to be able to like write down, but I would understand it for like the multiple choice questions because that could be helpful. All right, finally on to chapter 19. Describe the sampling distribution model of p hat. What assumption must you make for this description to be reasonable? So mu is equal to p and sigma is equal to the square root of pq over n. So to use the normal model, we must assume two things and then check the three conditions. So we must assume independence and that it's large enough. Then when we check the conditions, we're checking that it's random, 10%, and success failure. Let's see. What is the standard error of p hat? When would you use standard error in place of standard deviation? So whenever we estimate the standard deviation of a sampling distribution, we calculate standard error. Standard error of p hat is the square root of p hat q hat over n. And you need to highlight 1 and 2 off of this page. So again, with the next one, not necessarily that I'm going to ask you to answer that exact question, but you may be given a statement similar to it and be asked to explain what it means, or out of a multiple choice question to like pick what is meant by it. So explain the meaning of the following statement. We are 95% confident that between 42.1% and 61.7% of C fans are infected. I don't even know what that is. So that says that, or it gives our best guess of where our parameter is and how certain we are that it's in our range. What is meant by confidence interval? It is the estimate plus or minus margin of error. And it gives an interval that captures the true parameter value you'll need that one. What's the general form of a confidence interval for a one prop z interval? It's p hat plus or minus z star times the standard error of p hat. And z star is the z-score from the normal model for a corresponding percent so you'll need to know this formula as well. Explain how to calculate margin of error. Margin of error is z star times the square root of p hat q hat over n, where z star is the critical value and the critical values that you'll need to know we'll do at the bottom. And then the square root here is the standard error. And as the confidence level increases, what happens to the margin of error and what happens to the confidence interval? So as confidence level increases, margin of error increases, and the confidence interval increases. So they both increase. And you'll need 6 and 7. Number 8, we basically already answered previously in that fill in the blank question. But by how many times does the sample size n increase in order to cut the margin of error in half? Basically the same thing. It's a slightly different question, but it's still 4 times. Why is it best to have high confidence and a small margin of error? High confidence means our method almost always gives correct answers. Small margin of error says we have narrowed down the parameter precisely. You'll need to know that one. And then the critical Z value for each of the following. The only one that I'm actually going to sketch for you is number 10, but I'm going to write down what all the critical values are. So for 90%, Z is equal to plus or minus 1.645. For 95%, Z is equal to plus or minus 1.96. And for 99%, Z is equal to plus or minus 2.576. And you'll need to know all of those values to be able to use them. If you need anything other than those, I'll give it to you. So a sketch of this one here, whoa. So basically we're looking at the different number of standard deviations away. So at 1.645 away in both directions, this area in here is for the 90%. So 90% of the data is going to be in that range. All right, we'll finish chapter 19 and then, or well, we might finish the next page and then we'll save the rest of chapter 20 for tomorrow. So what assumptions or conditions must you consider before creating a confidence interval for a proportion? So these are the things that the assumptions and the conditions. So independence, random, 10% condition, large enough sample, and success failure. What effect does increasing your sample size have on the margin of error, and what effect does it have on the confidence level, and then what effect does it have on the confidence interval? So as n increases, margin of error decreases, confidence interval becomes smaller or more precise.
Oh, we're teaching?
Yeah, I have one more question. Why?
Well, she asked if there's anyone else that could live stream because they're not going. Because I think he has pneumonia again.
Oh gosh.
I think you got the text too, but you probably haven't seen it.
Oh, I haven't seen it yet.
I can just come back when you're done teaching. Just text me when you're done.
Okay. Sounds good. Huh? Her dad. All right, then the formula used to determine the sample size n that will yield the confidence interval for a population proportion with a specified margin of error is m is equal to blah, 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 solve for n. So, I mean, I think we've kind of done this before, but n is equal to z squared times p hat times q hat over m squared. And that's just from, in general, just solving for a variable to solve this equation to get this. But you'll need to know that, but if you know how to solve for a variable, you should be fine. What do you think? Stop there.